In this video, we're going to expand upon our understanding of what a compound is by looking at three distinct categories of compounds that can be distinguished from each other by looking at the chemical formula. The first of which are what we call the ionic compounds. Now, if the name ionic seems a little bit familiar, that's because the root of this word is obviously ion. Now, we remember that ions are simply atoms that have either a positive charge or a negative charge, depending on whether the ion forms based on losing electrons the way that metals do, or by gaining electrons the way that nonmetals do. Now, from this realization, we can figure out what type of compounds are ionic. For example, the most famous ionic compound is probably sodium chloride. Now, sodium, we remember from its Lewis structure. If we remember that sodium is in group 1, that means that it has one valence electron, and chlorine as a halogen is actually in group 7, meaning it has 7 valence electrons. Now, what this means is that an ionic compound can form when the metal loses its electron and gives it to the nonmetal, resulting in the metal having a positive charge, and after the nonmetal has gained electrons from the metal, it will now have a negative charge, and now we have an ionic compound. And this is basically an identical mechanism behind how ionic compounds form. For example, this white crystalline powder down here is potassium chloride. So we see one metal and one nonmetal. Potassium forms a positive ion by losing electrons, while chlorine forms a negative ion by gaining electrons. We can even see that there are examples of ionic compounds that contain a metal. Sodium is the metal in this white flaky powder here, and multiple nonmetals. So here we can see that oxygen and hydrogen together form the nonmetal negatively charged component of this ion here. This is actually a very strong base called sodium hydroxide. But again, because we can see that we have a metal and in this case multiple nonmetals, the principle of an ionic compound remains the same. Now, the opposite of ionic compounds are what we call covalent compounds, although depending on your chemistry teacher, they may use the word molecular compound instead. Now, molecular is an adjective, and if you figure out what the noun form of this word is, you will come up with the word molecule. Now, the word molecule refers to a type of compound itself that is made of more than one nonmetal that are joined together. And as we talked about when we talked about carbon and silicon, rather than one nonmetal giving its electrons away to another nonmetal, the way that ionic compounds form, covalent compounds, or molecules, if you will, form when multiple nonmetals share their electrons with each other. And probably the two most famous examples of covalent compounds are water, consisting of 2 hydrogens and 1 oxygen, and carbon dioxide, consisting of 1 carbon atom and 2 oxygen atoms. So because hydrogen and oxygen, or carbon and oxygen, are all nonmetals, we can see that neither water nor carbon dioxide are ionic compounds because neither compound has a metal within its chemical formula. Now, if we get more specific with covalent compounds, we can look at a third category of compounds that we call organic compounds. And as mentioned, organic compounds are specific covalent compounds in that every organic compound is based around the elements carbon and hydrogen as the most important elements within the chemical formula. For example, if we remember the chemical formula of sugar from the previous video, sugar is actually made of 3 elements, carbon, hydrogen, and oxygen. And if we take 6 carbon and 6 oxygen and 12 hydrogen, we can actually make a sugar molecule, or an individual unit of sugar. But again, we can see that carbon and hydrogen are the 2 primary elements in sugar's chemical formula. One of the simplest organic compounds is actually gasoline, that being the organic chemical that is put into motorized vehicles in order to give them power. The chemical formula for gasoline, the scientific name for which is actually a compound called octane, is C8H18. So we can see here that not only are carbon and hydrogen the primary elements of gasoline, but we can see that they are actually the only elements. Let's take a second here to fix the spelling of carbon before anybody else notices. Hopefully nobody missed that spelling mistake there. Finally, if we think about beverages that cannot be purchased by people younger than the age of 18, such as beer, wine, vodka, or your favorite type of alcohol, we call these alcoholic beverages because alcohol is actually the organic compound that is added to alcoholic beverages in order to give it that consistent flavor. And alcohol has this chemical formula here, C2H5OH. And again, we can see that the two primary elements within the chemical formula for alcohol are carbon and hydrogen, just as they are with any organic compound. In the next video, we're going to be taking a more detailed look at how to read chemical formulas and how to understand how many of each atom are required in order to make a compound. Before that, though, you can try the practice problems below just to make sure that you can distinguish between an element and a compound, and then, based on the chemical formulas that are given, distinguish between ionic, covalent, and organic compounds.